Hello students, in previous lecture you will know about the Rutherford's alpha scattering model of an atom, or you can say that nuclear model of atom, as well as the drawbacks of Rutherford's nuclear model of atom. Now students, Neil Bohr, today we are going to discuss about the Neil Bohr's atomic model. Neil Bohr in 1930 gave the concept of atomic structure of an atom, and he also gave following conclusions about the structure of atom. Look at on the concept that was proposed by Neil Bohr. Bohr stated that the electrons are revolving around the nucleus in a certain or definite imaginary orbitals known as stellar energy levels, known as stellar energy levels. If we are discussing about the cells and energy levels, then this is the nucleus containing proton and neutron, and around the nucleus there is certain spherical or orbital structures that are called stellar energy levels, as suggested by the Neil Bohr. This is K cell, L cell, K cell, L cell, M cell, and N cell. Likewise, he also gave the number to these cells: first, second, third, fourth, many more. Now, the second concept given by Neil Bohr was the total mass of or you can say that whole mass of atom is encloses into its nucleus. The nucleus is consists of the total number of protons and neutrons. Present in atoms. Next, he also stated that the electrons revolving around around the nucleus, they have capacity. They have capacity to gain or loss the energy level, gain or loss the number of electrons, gain or loss the energies, or you can say that energies. So when electrons loses its energy, then comes to in the lower energy level, comes to in the lower energy level, whereas when they gain the energy, or you can say that on gaining energy, they also achieve the higher energy level. They also achieve the higher energy level. It means, students, when the electrons revolving around the nucleus, then they not only loses their energy, but they has also capacity to gain energy. If they loses their energy in the form of electron, then they shift down to the lower cell or lower orbital or lower class or lower energy level. Students, these orbitals are known as the energy level, orbital or cell. These are the names of these orbitals. It's said to be cell, energy level or orbitals. If, let's take an example, if there is 3 electrons in the second energy level here, if it loses 1 electron, then it jumped into the lower class, it means in the K cell. Thus, during loss of electrons, the electron achieves the lower class, whereas if the number of electrons is increasing by the number 9, then it shifted from the class or cell L to M. This is the concept of the Neil Bohr. He also stated that to maintain a definite energy level, there is need each and every electrons to have a potential energy that is equivalent to H upon twice pi, where H is Planck's constant. It means the velocity through which the electrons are revolving in a definite orbital is maintained by this constant or this velocity. If they maintain the velocity h upon twice pi, then they always remain in the definite orbitals. Either if the fluctuation is caused in this velocity, then if increases, then they achieve the higher class or higher cell, and when it goes on decreasing, they jump into the lower cell or lower orbital or lower energy level. Now students, after this concept and this phenomena, Neil Bohr and Bury in 1921 gave a schematic concept to have the number of electrons in a definite energy level are set. How many electrons could be present or filled in a definite number of orbital or cell, that is determined by the following schema of Bohr and Bury, and this scheme is also famous as Bohr-Bury scheme. Now we are going to discuss about the Bohr-Bury scheme. Name Bohr and Bury scheme, which was laid down in 1921. Bohr-Bury scheme. According to this scheme, the maximum number of electrons in a particular cell energy level or orbitals can be determined by the formula 2n squared. By the formula 2n squared. Let us take the example of this system. Here I take the definite energy levels. Compare the energy levels with their principal number with formula 2n square, and the maximum number of electrons we obtained. The maximum number of electrons. Here I take K, L, M, N energy levels. The principal quantum number for K cell is 1, 2. This is the third cell and this is the fourth cell. Now when I compare these numbers with this formula, then here I am obtained the number is 2 electrons, and here 2 into 2 square, 2 is 4, 2, 8. Maximum number of electrons in K cell have 8 electrons. Likewise in M cell 2, the square of 3, 9, 9 to is 18. Maximum number of electrons can have the M cell is 18. Now M cell, the square of 4 is 16, and 16 into 2, 32 electrons. So on. Thus, the definite number of electrons can be determined by this first scheme of Bohr and Bury, as here given in the table. Now students, the second phenomena of their scheme was the outermost cell of an element. The outermost cell or energy level of an atom of element cannot have more than 8 electrons, more than 8 electrons. Either its penultimate cell is not completely filled. Either its penultimate or pre-existing cell is not completely filled. Not completely filled with electrons. Students, here I take an example of the element calcium, whose atomic number is 20, hence there are 20 electrons in calcium. Now here I give the electronic configuration. This scheme of the Bohr and Bury is also known as electronic configuration. It means the distribution of electrons. Now here I take the cell K, L, M, N. Then according to this scheme, the number of electron in maximum number of electron in K cell is 2, L cell is 8, as given in this first scheme. But if we are going to fill the M cell, there is need of 18 electrons, but this element has not 18 electrons remaining to fill this cell completely. Then there is follow the second group. The outermost cell or energy level of an atom cannot have more than 8 electrons. Either its pre-existing cell is not completely filled. Yes, students, here 10 electrons are remaining, but in the outermost cell we cannot fill more than 8 electrons. Then what is doing in this electronic configuration? In this electronic configuration, there may be 2 electrons. There may have been 2 electrons in the outermost cell, and the remaining number of electrons is filled into the pre-existing cell. Thus, this is the electronic configuration of the calcium. Here in K cell 2 electrons, L cell 8 electrons, in M cell 8 electrons, and the remaining electrons is filled in the M cell. This gave the another scheme and idea of the Bohr-Bury scheme. Bohr-Bury further states that the outermost cell, if the outermost cell of an electron of an atom have 2 electrons, then it is not necessary to have filled the pre-existing cell completely, or you can say that incompletely. It means if there is no more than 2 electrons can exist in the outermost cell, as given in this example. Now students, another and the last scheme was given by the Bohr and Bury was that any of the cell in any of the cell of an atom, electrons can be filled. It is not necessary to have 8 or 18 or 32 electrons. The number of electrons is filled into the each and every cell on the basis of the lower to higher cell. It means these are called subcells. More about the cell and subcells we are discussing in next lecture video. Thanks students for joining today.